Alright, welcome back. Drive-Through Confessionals, a 7-4 Notes edition. Shout out to my study hall. Hardest working kids in the school. Second bell, what? Today's lesson is brought to you by the deli. Hungry for some cookies? Stop by the deli. Get yourself a cookie. Soon to be serving coffee by the cup. Alright, this lesson is all about regular polygons. So at first we have to have a good definition of what a regular polygon is. So simply, a regular polygon is a polygon with congruent sides and angles. So far in this class we've studied two primarily, and that is the equilateral triangle and the square. So one thing that's important to remember is if a triangle is equiangular, then it has to be equilateral. But that's not true for any other shape. So you can have an equiangular quadrilateral. It's a rectangle. It's not necessarily regular. So in order to be regular, we need for all the sides and all the angles to be congruent. Let me pull up and see if I've got a pentagon shape that I have, and I do. So we'll make that one the next one. And what we'll be doing today in our notes very quickly is kind of taking a look at what happens to the interior angles of our regular polygons as the number of sides increases, and what happens to our exterior angles. So what I'll do now is I'll draw just a single exterior angle for each one of these. And I just want you to notice that angle 1 is obtuse, angle 2 is right, and angle 3 is acute. So as the number of sides of a regular polygon increases, the measure of the exterior angle decreases. And that has to do with what we learned yesterday. So we remember that the sum of the exterior angles is always 360. So the first theorem that we'll learn is to find the measure of an exterior angle in a regular polygon we simply take 360 degrees and divide it by the number of sides. So in the case of our pentagon, (360) divided by 5 is 72 degrees. And that means the measure of each exterior angle is 72 degrees. And I'll just stop at that. Okay? Now, remember that because we'll come back and we'll find it a different way later. Okay? The second piece of notes from this section, which is not listed in your book, and I'm not exactly sure why, but it's pretty intuitive, is that the measure of each interior angle of a regular polygon. And we're going to figure out what that equals. But before we figure it out, we're going to make some more pictures and try to teach ourselves. So once again, here's a regular triangle, a regular quadrilateral. Let's redo that. A regular quadrilateral called a square. A regular pentagon. And we got room for one more. So we'll put a regular hexagon right there. And minimally, what we want you to see is that angle 2 is clearly bigger than angle 1. Angle 3 is bigger than angle 2. And angle 4 is bigger than angle 3. So as the number of sides of a regular polygon increases, the measure of the angle also increases. And we're simply going to find that this one would be 180 divided by 3, which is 60 degrees. This one would be 360 divided by 4, which is 90 degrees. This one would be 540 divided by 5, which is 98 degrees, I think. And this one here would be 720 divided by 6, which is 120 degrees. Nick, did I get any of that wrong? Are you paying attention? Chris? Okay. All right, so how do we come up with that? What if our regular polygon had n sides? Well, clearly what we're doing here is we're finding the measure of the sum of the angles. And yesterday we learned that's n minus 2 times 180. And then we just divide that by the number of sides. Okay? Now, so let's just remember, we already figured out from the last slide that a pentagon was 72 degrees for the exterior angle. It's 98 degrees for the interior angle, and that makes me feel good because 98 and 72, that's not good. We got 98 wrong. That's what I thought. This is 108. This should be 108. So what I just explained there is a nice way to always check yourself. You've got two ways to find the exterior angle. You can find it by dividing the number of sides into 360, or you could just find the interior angle and find its supplement. That's a nice way to catch some mistakes. As you can see, I did that right there. Okay, so let's go over one type of example problem that might help you. Oh, what if we said, find the number of sides in an equiangular polygon if its interior angle is 156 degrees. So one interior angle equals 156 degrees. What kind of regular polygon is this? Okay, so we're just going to say that 156 is equal to n minus 2 times 180 divided by the number of sides. To solve this problem, I would simply multiply both sides by n. That cancels it on this side. I get 156n is equal to n minus 2 times 180. I'll distribute, and I get 156n is equal to 180n minus 360. Subtract 180n from both sides, and I get a negative 24n is a negative 360. So n is going to be 360 divided by 24. Is that 15? So this is a pentadecagon. Drink some of Nick's coffee. It's cheap, and it goes to a good cause. Boom.